All right, let's look at some problems where we have the square root in the denominator, and our goal is to rationalize the denominator. What that means is, well, let's look at something like 20 over the square root of 5. It's considered to be poor form in math to leave a square root in the denominator. So we need to get rid of that square root of 5 somehow. Well, we learned when we were multiplying square roots together that if I had the square root of 5 and I multiplied it by the square root of 5, then that would just give me 5. So that would get rid of the square root in the denominator. So I'd love to just multiply the denominator by the square root of 5. But we know that with fractions, whatever you do to the bottom, you have to do the same thing to the top. So I'll multiply both numerator and denominator of my fraction by the square root of 5. When I do that, I end up with 20 square root of 5 over square root of 5 times the square root of 5 gives me, well, the square root of 25, which is just 5. Now, always check to see if you can do some simplifying in your fraction in the end. The 5 in the denominator is outside of the square root, so it cannot reduce with the 5 underneath the square root. You could think that the 5 underneath the square root is in jail, and it can't touch things on the outside of the jail. So these 5's cannot reduce down. However, 5 can reduce with 20. 5 goes into 20 4 times. So I can rewrite this as 4 times the square root of 5. What we've really done is we've gotten rid of the square root in the denominator, and I have 4 square root of 5 is considered a more simple form than 20 over the square root of 5. All right, let's look at another example of this. What if I did something like 7 over the square root of 8? Again, our goal, get rid of the square root in the denominator. And the way that you do that is you multiply both numerator and denominator by that square root. So I'll multiply top and bottom by the square root of 8. Now when I do that, I've got 7 times the square root of 8 over the square root of 8 times the square root of 8 is the square root of 64, which is just 8. Now you might say, okay, I'm done. 7 and 8 don't reduce. But the square root of 8 is not in simplest form. So I can actually split up the square root of 8 into, well, 8 factors into 2 and 4, 4 factors into 2 and 2. So one of my 2's will come out, one of them goes away, and that last one will have to stay under because he doesn't have any twins. Now when this 2 comes out over here, and when I rewrite the square root of 8 as 2 times the square root of 2, the 2 that came out will have to multiply by the 7 that's already out there. So I can rewrite 7 radical 8 as 7 times 2, which is 14, times the square root of this 2 stayed under, all over 8. Now, 14 and 8 can reduce. Both of those are divisible by 2. 2 goes into 14 7 times. 2 goes into 8 4 times. So my fraction will then can be written as 7 times the square root of 2 over 4. Now you might be wondering, is it okay to have a square root in the numerator? And the answer is yes. No square roots in the denominator, but square roots in the numerator are considered to be fine. In fact, there's no way you can get rid of it in both places. Okay? All right. Let's look at one more example. How about something spiffy like the square root of 18 over 4 times the square root of 2? Now my goal is to get rid of the square root in the denominator. So I need to get rid of the square root of 2. To do that, I'll multiply the denominator and the numerator by the square root of 2. Now the square root of 18 times the square root of 2, we learn that we can just do the square root of 18 times 2, which is 36. All over, now 4 stays out, square root of 2 times square root of 2 is the square root of 4, which is just 2. So again, When you have 4 radical 2, you can just multiply the square roots together, and this 4 will stay out. So I now have the square root of 36 is 6 over 4 times 2 is 8. Now 6 over 8 is a fraction I can reduce. Both of those are divisible by 2. So if I divide numerator and denominator by 2, this gives me 3 over 4 as my final simplified fraction with no square roots in the denominator. Alright, so I think that this is probably the newest thing you guys have learned. And just remember, multiply top and bottom by the square root that you see in the denominator. Square roots in the numerator are fine. If you're having any troubles, send me an email and cite an exact problem that you're not understanding, and I'll see if I can pinpoint where you're making a mistake or how I can help. If you need help solving quadratic equations,